Well, hello everybody, and welcome to Thursday. Today we are learning about graphing linear equations, and I know we've been doing this for a little bit, but today we're going to learn how to graph them without the use of a table of values and without the use of the Desmos graphing calculator. Okay, and then once we get done with that, there is a project for you on Google Classroom, and the code is listed here on the Canvas posting for the Google Classroom if you didn't join at the beginning of the semester or if maybe you accidentally deleted it. And the reason we're going to use Google Classroom for the project is because you're submitting multiple files, and it's a little bit easier to do that with Google Classroom than it is with Canvas for what I've got planned. All right, so let's go ahead and roll into our lesson today about graphing linear equations in slope-intercept form. Like I mentioned earlier in the week, you do need graph paper to do this assignment. All right, so what we already know how to do is to take a table of values, and when we take a table of values, each of these is an ordered pair, and each ordered pair makes a point on our coordinate plane, and so we can graph those points, and then we can connect those points with a line, and any time that a function creates a line, it's called a linear function, because the word line is in linear and it creates a line. The other thing we know how to do is to just simply type the equation of a line into Desmos, and it will graph the line for us. And here, of course, is your y-intercept, and then your slope is 2. So it's a rise of 2 and a run of 1 from one point to the next. All right, so those are the things we already know. So if you come over here and open up these guided notes for today, what we're going to find here is this is pretty simple to do about graphing a linear equation in slope-intercept form. Okay, so slope-intercept form we know is y equals mx plus b, where m is your slope or your rate of change, and b is the y-intercept. Okay, so I know all of you know that by now, that m is your slope or the rate of change, and then b is the y-intercept, okay? And you can just abbreviate y-intercept with y hyphen int, okay? So if we come down here to block number 4, all we need is the slope and the y-intercept of a line to graph a line from the equation. So block 4 down here says, how do you graph a line? So number 1, plot the y-intercept, also called b. So over here in our equation, y equals 3x minus 2, that y-intercept is going to be the ordered pair of 0, negative 2, because wherever the x value is 0, that is your y-intercept. So I'm going to make a point here at 0, 2. Then, step 2 says, start at the y-intercept. That's why from the very beginning, we've said the y-intercept is our starting point. So when you go to graph a line, that's where you start, and you start your graph using the slope to count up or down, if it's positive or negative, the number of spaces indicated by the numerator, then you count to the right the number of spaces indicated by the denominator to plot the second point. So all you're doing, everybody, is what I taught you from the beginning, is rise over run. So if I look here, my slope is 3x, which as a fraction, that means it's 3 over 1. So I'm going to rise 3 on my y-axis. So that means I count up. So I start here at negative 2, 1, 2, 3, and I go over 1. And then I count up again, 1, 2, 3, and go over 1. Rise over run. Okay? That's all you're doing, is rise over run. And then you connect your points with a line. Okay? Now, whenever you make a line, the minimum of points that you need is 2. Sometimes you can draw 3, 4, or 5 if you want to get a better idea of what your line is going to look like. But the minimal amount of points that you need to graph a line is 2. All right? So let's look at example number 2. Or example 1, I'm sorry. Example 1 says y equals x minus 4. So in this particular equation, my slope, or my m value, whenever x is by itself, that means it has a coefficient of 1. So it's going to be 1 over 1. That's how I write 1 is a fraction of itself, 1 over 1. And then the b value, or the y-intercept, remember, whenever it has a negative in front of it, that means it is a negative y-intercept. So that's going to be 0, -4. All right, so let's follow our steps. First thing I do is plot my y-intercept at 0, -4. So here's my origin 0, 0. I go down to -4 and I place a point there. All right, so the next thing is to start at the y-intercept and count rise over run, or plus. And remember, we always graph from left to right. Even when you're graphing a negative slope, you always graph from left to right. So I start at -4, I go up 1 and over 1, make my next point, up 1 and over 1, make the next point, up 1 and over 1, and make the next point, and then I connect my lines, my points with a line. If we look at the next example, I have y equals a -4/3 x plus 2. So here my m value, or my slope, is going to be a -4/3. And my y-intercept is going to be 0, 2. Okay, so I start at 0, 2. So I'm right here on my y-axis. Now, this is a -4/3. So that means I'm going to go down 4 and over 3. And remember, I do this from left to right. So I start here at 2 and I count down 4 on my y-axis. So 1, 2, 3, 4, and then over 3, and that puts me right over here. And since I would run out of room, I'm just going to use my 2 points, because I can draw a line if I have 2 points. Kind of missed my point there, but there you go. Okay, so if I look here at numbers 3 and 4, or excuse me, 7 and 8, again, same thing, y equals -4x minus 1. So my slope here is going to be -4 over 1. And then my b value, or my y-intercept, is going to be 0, -1. Okay, so same thing, I start at -1. And I'm going to count down 4 and over 1 because it's negative. And I do this from left to right. So I start at -1, and if I count down 4, 1, 2, 3, 4, and then over 1, it puts me right here. And there's my line. And then for example number 4, -x plus 2. So again, my m value this time would be -1 over 1, because anytime x is by itself, 1 is the coefficient. So 1 is a fraction of itself, is going to be -1 over 1 in this case. My y-intercept is 0, 2 again. So I would start here at 2, 0, 2. And this time I travel down and over again. So I go down 1 and over 1. Down 1 and over 1. Down 1 and over 1. All right, so before you do the rest of the examples, I want you to go with me over to the Google Classroom page, okay? And the code is in Canvas if you've accidentally deleted the Google Classroom or hadn't joined from the beginning. And over here in the Google Classroom, this is what you're going to work on today, if you like, definitely on Friday, and this will be due on Monday. And this is called the Planning a City project. And what it says here is, for this assignment, you will be planning the road system and features of a city. You will need a sheet of graph paper, a ruler, and markers or colored pencils/pens. When you're finished, upload a copy of your graph paper and submit through Google Classroom, the document will automatically submit as well. Okay, so this is set up to make a copy for each student, so you're all going to get your own copy. All right, so when you open this up, all of your instructions are contained in the document here. Okay, it lists your scenario here as you are a member of the City Planning Commission and with an established city that is just beginning to grow. You will need to put a plan in place so that your city will grow successfully and have an efficient road system. All right, so here's what you need to do. First of all, give your city a name. Okay, then on a sheet of graph paper, okay, you will need to prepare a grid and locate landmarks and plan the street layout. Okay, so you create your coordinate grid on graph paper. The origin should be in the middle. So find the middle of your page and place your origin there. Each unit on your paper is 1/10 of a mile. As you add features to your city, be sure to mark and label each one on your grid. Okay, so what you're going to do is start with these landmarks here. You have a courthouse, an electric company, a school, a historic mansion, the post office, and then there's a river. And it says here, a river runs through your city following this equation, y equals 2x minus 5. Use a blue marker or pencil for the river. There's a main highway that goes through the city, and it follows the equation y equals a negative 4/3 x plus 4. And the only other paved road is First Street, which runs from the courthouse to the electric company. Okay, so I put an example here called planning a city. And this is what it would look like so far after you do those first few items. Okay, so you see how the river is in blue. Then I've graphed First Street using the equation of the line that was given. Or excuse me, I graphed First Street based on what I was told to do. I graphed the river and the main highway based on the equation of the line that was provided. Okay, so here's the river, y equals 2x minus 5. And then here's your main highway, which was the negative 4/3 x plus 4. All right. So all of these other things here are the little landmarks. So the courthouse, I drew the scales of justice. Here at the school, that's supposed to be an apple. Here's a letter for the post office, a light bulb for the power company, and then a house that represents the historic mansion. Okay, so that is this first part done here. All right, it also tells you to graph a tourist center. Okay, so as you go through this, you're going to be asked to plan some new roads, and it's going to give you equations to draw as the plans for those new roads. Then you're going to draw some other new roads, and there are some equations given here for you to draw as well. And you need to answer all these questions that are in the bold. You're going to find some midpoints again, which is something that you did at the beginning of the year. And then you're going to plot some more places in your city. Okay? So this part is going to be due Monday. Okay? So all you need to turn in for today is the examples here, the remaining examples to do. So 9, 10, 11, 12, 13, and 14. Turn that in today, and then you can start on the Planning a City project, and the Planning a City project is due Monday. So this will be your Friday and Monday work. All right, so I will be on Google Meet. If you need anything, please come and see me. If you have any questions, please email me. And have a great Thursday.